Boyle's law, sometimes referred to as the Boyles-Mariotte law, states that the absolute pressure and volume of a given mass of confined gas are inversely proportional, provided the temperature remains unchanged within a closed system. This can be stated mathematically as follows. P1 times V1 is equals to P2 times V2. History and derivation of Boyle's law. The law was named after chemist and physicist Robert Boyle, who published the original law in 1662. Boyle showed that the volume of air trapped by a liquid in the closed short length of a J-shaped tube decreased in exact proportion to the pressure produced by the liquid in the long part of the tube. The trapped air acted much like a spring, exerting a force opposing its compression. Boyle called this effect the spring of the air and published his results in a pamphlet with that title. The law itself can be stated as follows. For a fixed amount of an ideal gas kept at a fixed temperature, P for pressure and V for volume are inversely proportional. That is, when one doubles, the other is reduced by half. Spray paint.
Do you ever wonder why there's a ball inside the spray can when you shake it?
Before you spray a can of paint, you are supposed to shake it up for a while as a ball bearing rattles around inside. There are two substances inside the can. One is your product, paint for example, and the other is a gas that can be pressurized so much that it retains a liquid state, even when it is heated past its boiling point. This liquefied gas has a boiling point far below room temperature. Because the can is sealed, the gas is prevented from boiling and turning into a gas. That is, until you push down the nozzle. The moment the nozzle of a spray paint can goes down, the seal is broken and the propellant instantly boils, expands into a gas, and pushes down on the paint. Under the high pressure, the paint is forced out of the nozzle as it attempts to reach an area with lower pressure.
Why does a ball bounce back to you?
A basketball is held at a certain volume and pressure at constant temperature. When it hits the ground, the volume decreases and the pressure increases, and the increasing pressure springs the ball back up at you. There is the issue of the elasticity of the rubber, but the decreasing volume, increasing pressure of the bounce is an application of Boyle's law.
Why is it not advisable to shake a can of soda before opening it?
Happens because the liquid is pumped full of carbon dioxide, causing it to bubble up as the carbon dioxide makes its escape. When a soda bottle is filled, it is also pressurized. Much like the aerosol can mentioned earlier, when you slowly open the cap, the gas is able to increase its volume and the pressure decreases. But if the bottle is shaken up and the gas is mixed into the liquid, then you may have a mess on your hands. This is because the gas trying to escape is mixed into the fluid. So, when it does escape, it brings the foamy liquid out with it. Pressure in the bottle goes down, volume of the gas goes up, and you have yourself a mess to clean up. We showed you the different real-life applications of Boyle's law, but we haven't showed you its use underwater. So in this experiment, you will see how the bubbles behave underwater. For the procedures, Step 1. Attach the hose of the air pump to the bottom part of the empty container using a tape. Step 2. Fill the empty container with a considerable amount of water, enough to witness the rising of bubbles. And for Step 3, pump air to the water-filled container and observe how the bubbles behave. That is, if the pressure increases, then the volume occupied will decrease, and if the pressure acting on the gas decreases, then the volume occupied by the gas will increase. And the rising air bubble, as the pressure is decreasing, the volume and hence its size increases. Thanks for watching!